Hi everyone. Looks like there are not many people here. Let me check this. Hi everyone. Okay, let's start with the homework problem I gave yesterday. And here's the link to it. Anyone had any idea solving this problem? Okay, let's explain the problem. So the problem states that you are given a tree and there are two players who are playing a game on this tree. And for each turn, every player or the current player in the turn select a leaf node and then remove it. Okay, so let's draw this. I think you'll see this, right? Okay. Okay, this is a tree, and for the game to move, each player in each player's turn he selects one leaf and then removes it. So if player one is in its turn now, it selects, for example, this leaf and then removes it along with its edge. Okay, so now we have only this tree, and then the second player removed this edge, this leaf, for example. Then the third player removed this leaf, for example, and so on. Okay, and after removing all of these, this will be a new leaf, right? So one can remove it also, and then they'll do this until what? Until someone removes the special node X. Okay, so the one who removes this special node X is the winner of the game. So the program asks us to determine. Okay, so can you? The problem is to determine who is the winner of the game if all of them plays optimally. Okay. So if I have player one, player two, they are Ayush and Ashish. Okay, doesn't matter now. We have two players, one and two, and and one will start the game and two will follow him, and then they will alternate turns. So one will play, then two, then one, then two, and so on, until someone wins. But the two of them plays optimally. So every one of them wants to win. Okay, so at some point, everyone will make at any point everyone will make the optimal choice to make himself win and to make the other lose. Okay, so let's take a simple tree here. Okay, so this is X, and for the two players they want to remove X, right? So it's clear that for anyone he will for anyone to play optimally. So for example, if the first player starts now, he will choose not to remove this leaf, right? Because if he removed this leaf, then the other player will remove X, so he will lose. So whenever there is one leaf after X, so no player will choose to remove it because X will be left to the other player. Okay, so if we have something like this, So no player will choose to remove this. Okay, so the turns will go like this. The first player will remove this. This is the first player, and then the second player will remove either this or this, either this or this. But they are relatively the same, because if the second player removes this, then the first player. Can you see my cursor where I'm pointing, or the pen? Okay, let's. Okay. Can you see a red dot here? Red dot. Anyone talk to me? Anyone speak? Okay. Now you can see. Uh, so now, as I said, let's redo this. As I said here, the first player cannot remove this leaf from the first time. Okay, because if he removes this, then the second player will remove X. So first player will lose. So no one will choose to remove this. So at the first time, player one have no choice but to remove this node. Okay, and after he removes this node, we are left with these three nodes. So the second player will choose to either remove this or remove this, but they are the same. If the second player removes this, then the first player can remove X, because X will be a node, and if second player removes this, then he can remove X. So it's clear then that if you have, let's have a more complicated tree here. Okay. Let X be the root of the tree. Okay, so to make things easier, we'll take X and then make it the root of the tree. So any other childs will be below it, to be something like this. Okay, and so on. Okay, so this is a big tree. Okay, so at the first time, no one can remove X because X is not a leaf, and you have only leaves out here that someone can remove, right? So what's the leaves that the first player will choose? Actually, it doesn't matter what is the leaf that the first player will choose, because everyone will remove any leaf until we are at the end at something like this. And that's the case that's left at the end, because everyone will remove any leaf until we are left at this, and then everyone will be afraid to leave X as the leaf, right? So again, everyone will remove, if you are at something like this. So let me get the spotlight. If you are at the end at something like this, so each player, if he chooses any leaf here, it doesn't matter what leaf to choose, because if you choose this, then X is not a leaf, and if you choose this, then X is not a leaf. So after getting to this shape, we will be ending at something like this, exactly something like this. Okay, because, so for example, first player remove this, and then second player remove this, so we'll end at two leaves after X. So after this, the second player who make a moves will lose. So if we are left at three nodes here, X and two nodes here, so if player one removes this, then player one will take X, and if then player two will take X, and if player one remove this, player two will take X. So eventually, if you are at something like this, then the player who makes the move lose. That's it. Okay. Um, to make it easier to solve this problem, we are thinking backwards, not forwards. So we are thinking about the winning state, not how everyone will perform the move. So the winning state will be something like this, and the losing state will be also something like this. At the end, the player who reaches these states wins. Why? Because the player who reaches this state just will take X, right? So we found now that um, if a player wants to win, then he must be left with two nodes, right? So let's calculate now how every player. Let's calculate now if player one wins or lose. How could we get that? So here is this. Okay, we said that this is a winning state. So whenever any tree we have, let's say you have a tree of 5 nodes. Actually, let's say it's of 2 nodes. Okay, so a tree of 2 nodes. Let's go to the editor to write. Hmm. So as I said here, the winning state is will be left with only 2 nodes, and it is X and another leaf. Okay, so if I have a tree with 2 nodes, then of course X will be one of them, right? So player one will wins. Okay, so one wins. So now I'm writing player one wins. So player one wins if we are left, of course, with 2 nodes. So if the tree is given with 2 nodes, then player one will play just take X. Okay. But what if we have 3 nodes, and of course X is not a leaf? So if X is initially not a leaf, and we have 3 nodes, then of course player one loses, because player two because player two uh, will just remove X after player one removes any leaf node. Okay. To go back, if we go back to the whiteboard here, I think you can see it. And we have 3 nodes here, and X is in the middle. So player one, if player one will remove any node from this, either this or this, right? So if player one removes any node, then player two wins. So now we said that if we started with 2 nodes, then one wins. And if 3 nodes, then two wins. I think you can see the drawing, right? Yes, I think yes. Okay. So as I'm saying here, three nodes, then two wins. So let's look at 4 nodes. We'll have X somewhere. Note that I'm saying that X is not a leaf, okay? Because if X is a leaf, not like this. If X is a leaf, then for sure, if the degree of X, so if it has only one adjacent node, then of course X is a leaf, then one will win, okay? So I'm talking here about the case where X is not a leaf only, okay? So here at 4 nodes, we'll have anything like this, for example. At 4 nodes, player 1 will also win. Why? Because player 1 will remove any node that's not this, because player 1 cannot remove this, because player 2 will win. So player 1 will remove this. Then player 2 will remove anything, this or this. So player 2 will remove, for example, this. Then player 1 wins. Okay? So what we a good observation here is that a good observation here is that if n is even, or actually if n minus 2 is even, and it's the same of n is even. So if n minus 2 is even, then player 2 wins. If n minus 2 is even, then player 1 wins. Because if we have 2 nodes, then player 1 wins. Player 1 wins. If we have 2 nodes, if we have 4 nodes, if we have 6 nodes, if we have 8 nodes. Why? Because if we have 2 nodes, then player 1 will remove x. If we have 4 nodes, then player 2 will remove a node, then player 1 will remove a node, then player 2 will remove, then player 1 will win. Okay? So actually, player 1 will win if n minus 2 is even. And n minus 2 is even means that if n is even. And vice versa will happen. So player 2 wins 1, 3, 5, 7. Okay, let's look at the last example to make things clear. If you have something like 5 nodes, anything like this, okay, then player 1 will start, remove any node, it won't matter if we remove this, for example, let's say 1, okay, then player 2 will remove any node, but he cannot remove this, okay, because if player 2 remove this, then player 1 will win. So player 2 will choose to remove a node that will not leave x as a leaf, okay, then player 2 will remove this, then player 1 will remove this, this is 1, okay, and then this is 2, and then this is 1, and then 2 will remove this, okay. So 2 will win here if I am at 5, okay. Let's say if I'm at 6, then player 1 will remove this, player 2 will remove this, player 1 will remove this, then player 2 will remove any one of those, then player 1 will remove this, okay.
After player
yes, what's the question?
After player 2 removing on the second one, anyway the x will become leaf node, right?
No, I didn't get you quite well. So here, player 1 will remove anything, then player 2 will remove this. Okay.
Then
then player 1 will remove anything from these leaves. Okay.
Yeah.
Then
So
player 2 will have no.
At this point, if the player 1 removes that, then the second player can select x, right? Since it has x has become a leaf node, right?
No, x now is not a leaf. So x is a leaf only if and only if it has only one adjacent node. So x is a leaf if it's something like this only. If x has any other adjacent node, then it's not a leaf. Okay. So it's a leaf only if it's something like this. So after player 1 remove this, and then player 2 remove this, and then player 1 remove this, we will have x not a leaf. Okay? Are you okay with this? Okay. So after this, player 2 will remove any node from these 2 nodes, then player 1 will win. Okay? So after drawing multiple trees, we will now have proved that if n is even, then always player one will win, and if n is odd, then always player two will win. Okay, but we need to check another thing. If x is leaf, so if x is leaf, then straightforward player one will win. Okay, so if x is leaf, so no matter what are other nodes, then player one will just remove x. Okay, so the code is simple, but we have to come with the idea first. So we have came to the idea now, and we want to write the code now. Okay, so let's see the input. Okay, we are given t, which are the test cases, and now we're given the description of the tree and x. And x. Okay. So now how will we store the tree? So we are only interested about the number of nodes and if x is leaf or not. And how to know if x is leaf or not. We said that x is leaf if and only if it has only one adjacent node. Okay. And of course, if n equals to 1, then if x equals to 1, then player 1 will win. So actually, this is only the one exception. So player 1 will win if n equals to 1. Because if n equals to 1, then we have only one node which is x. So player 1 will remove it. Okay. So player 1 will win at any even number of nodes and 1. Player 2 cannot win at n equals to 1. Okay. So here we want to store the number of adjacent nodes to any node because we want to see if x is a leaf or not. So if the adjacent nodes of x equals to 1, then we are done and player 1 wins. Okay. Okay. So a degree, the number of adjacent nodes to a node is called the degree of a node. Okay. So the degree of a vertex, number of connected vertices to it. Okay, so the degree of a vertex, and this is called the degree of a vertex. Degree of a vertex is the number of connected vertices connected to it. Okay, so we want to store the degree to each vertex after we take it, and then see if if the degree of x is 1 or not. Okay, we'll take n here, x. Then will be okay. So to store the degree for any integer, we'll make an integer array called degree of size n. Okay. Make it n plus 1 actually, because there are n nodes and they are from 1 to n. Okay. And then we'll take exactly n minus 1 lines describing the tree. Okay. At every line, we have two nodes, int a and b, and they are connected to each other. Okay. So how will we connect them? We will just add the degree to each of them. So degree of a plus plus and degree of b plus plus. That's it. Because a is connected to b, then degree of a will be increased by 1 and degree of b will be decreased by 1. I want to initialize this by 0, of course. And then what's the problem? Okay, then that's it. So now we are saying that if n mod 2 equals to 0, then player 1 wins. What is player 1? Ayush. So Ayush is player 1. So if n mod 2 equals to 0 or n equals to 1 actually, or degree of x equals to 1. So if degree of x equals 1, then it's only connected to one node and it's a leaf. Then player 1 wins. Okay. Then out Ayush. Else out and Ashish. So that's it. If n not 2 equals to 0, or n equals to 1, or degree of x equals to 1, then Ayush wins. That's it. Any question about this problem? Okay, let's try it. Yes, I didn't take A and B. Ashish. Okay. Ayush. Okay, I think this is okay. We'll submit the code. Okay, here is the submission link to the problem. Sent it. Let's move on to the next problem. Let's go to this. I'll send the link here in the chat. Take 3 minutes to read it, and then we'll discuss it with each other. If you have any ideas, talk immediately.